Hi, I'm Mike Dalton with Guided Innovation Group, and it's my pleasure to be with you here today, where I'll be sharing how you can create a competitive advantage by automating your project planning and full kitting. I'll start with a little bit about the problem that automation can solve. Then I'll jump to a live demo of an automated planning configurator so you can see how they're built and used. We'll talk about implementation and what kind of companies can benefit. And if you're part of the live audience, just type in your questions as we go because we've set aside time at the end so we can answer as many of those questions as possible. Abraham Lincoln famously said, "Give me 6 hours to chop down a tree, and I'll spend the first 4 sharpening the axe." Now, applying Honest Abe's advice to the world of project management, if we consider the time and effort any project takes, without good planning and preparation, there's a higher likelihood that your project is going to take longer and even end up with a fire drill like you see here. But with the investment of good upfront planning work and full kitting, you'll see faster execution plus less chaos as you near the finish line. And when I talk with leaders across industries, I find nearly universal buy-in for the necessity of good upfront planning. It's just common sense. Unfortunately, common sense isn't always common practice, and there can be lots of reasons for that. So I want to share a quick story about a client where we implemented critical chain for product development. It was more than 10 years ago, but they did everything right. Their cross-functional team built a robust project network. They created clear definitions of who does the work and what done looks like. They built a library of templates to speed planning. They implemented WIP release to optimize flow, and they put full kit discipline in place. By the time we got through implementation, they were already seeing much better results. More projects finished, projects finishing in less time, and greater than 90% of their projects finishing on time. But even after that implementation, there was still a struggle going on. And it made us worry, quite frankly, about the sustainability of the implementation. Because product managers were just having a heck of a time getting their cross-functional team members to spend a day or two building good quality plans. Now, at first, that made no sense. The people who had originally complained the most about not having inputs were the ones not participating. But when you think about it, this was an organization that had gone from zero planning, or at most a series of checklists, to something as comprehensive as critical chain. That can be a lot for people to swallow. And cross-functional teams include people from manufacturing, procurement, supply chain, quality, all the operations that are part of keeping the plant running and sales moving out the door. So even when you limit the project workload, these folks are already busy with a lot of other daily activities. Many of those more urgent than participating in lengthy planning sessions. Not more important, but urgency usually wins. So there were really 2 possibilities. We could crack down on the offenders, and it never goes very well when you try to force busy people to participate when they don't have time. Or the second one, we could return back to some common sense and really find a way to make planning much faster. So that's what my team did. Over the next few weeks, we helped them build an automated project configurator. It's 10 years later now, and the latest version is far more powerful, but even that first simple version dramatically cut their planning and full kitting time. What used to take a half a day to several days could now be done in 30 minutes to even just a few hours. Working from the configurator on a laptop, any team could build a solid plan and have it up and running in just a few hours in their planning software. And that's a meeting that even busy people can fit into their calendars. So that's the problem that automated planning solves, making time for the entire cross-functional team to be able to participate. which is essential if you want realistic plans that your teams buy into and are 100% committed to delivering. So in case you'd like to build a configurator of your own, let me jump over to the demo of the latest Excel configurator that we've built. It has 10 years of improvements baked in, so you really are going to be seeing what I'd call the full Monty here. But I'll show you how the planning team uses it and even some of the challenges that we've overcome. So I think the best way to show you how to build a configurator is to actually walk you through the configurator that we use. And what you'd normally do is, this is an Excel spreadsheet. It's an Excel workbook, a macro-enabled workbook, and it gets opened by the project manager at the beginning of the planning and full kitting meeting, and they either share it on a laptop with everybody or put it up on screen, or in more cases than not these days, they end up putting it up, showing it in Teams or Zoom so that everybody in their different locations can see it. And then with the whole team pulled together, gathered together, what we do is walk through basically all of the questions that are necessary to know whether we've got a completed project, whether we have the full kit to do the project as its charter is calling for, or whether there's something missing and we need to go back and do some additional work, or whether we can then get started. So it starts with very simply determining at what stage is the project going to start. And so here you can see 2, 3, 4, or 5, and this can be configured however you would want, but let's say that project starting at stage 2, which is typically some sort of concept development. And then in this particular case, I've got 3 choices. Is this an R&D mechanical project, an electronics project, or a software project? And it can actually be all of those. So this could be yes for mechanical. I'm gonna make it no for electronics. No, let's go ahead and make it yes. We'll make it yes for all of them. That'll show you the most. And then also, it's even a software project. So we're going to say yes for software. Now, if I said no for software, then what happens is that a number of things inside the rest of the questions get grayed out. For instance, you'd see that there would not be any. These are black, so there's no room here for additional. There's no way to select a project manager for a software project if it's no. So no software resource. So these questions, as you answer them, end up driving a lot of the rest of what you see here. And then you'll notice that as soon as these were turned to yes, then these all turn black, so they can't be changed. So you can't have an R&D project that's also an applications engineering project, or that's also a value analysis, value engineering project, or a cost reduction project. These are kind of mutually exclusive the way it's set up. So then that opens up the possibility over here to put project ID. So let's say the project is ABC, and we can even then select the product type. Oh, by the way, you probably noticed here that this gives us the capability to put information in here in each one of these. In most of these, you have the ability to put in a pop-up with information, so the team, if they've got any questions about well, how do you create a correct product ID? Product type is a drop-down. Drives, controllers, control systems, transformers, tooling, presses, CNC machines. So let's say this is for a drives project. What region is going to lead the design? Let's say it's going to be the U.S. And then you can even put the date issued. So we'll say this is going to be on 4/13. And you can see it even forces you to choose the right format for the date. So it'll be 3/14/2024. There we go. And that's the number of concepts in the stage. Is the next question. So how many round one proof of concepts would there be? And maybe there'd be one. How many in stage two? Let's also say one. Is a non-infringement study required? And again, what we're doing here is by the answers, right? If I were to change this to 3, then it would actually create 3 lanes of proof of concept. So now if I hit same thing here, non-infringement study, this would be, do we need to verify whether or not we've got a patent issue? Then I could say yes or no, and let's say it's yes. So now there's going to be some time in there to do a patent study to make sure we're not infringing. And then also, are we worried about being able to patent it? And we're going to say no at stage 2, but at stage 3, yes. And so those are mutually exclusive. Then industrial design input required. We're going to say no. This one doesn't have to go through an industrial design review. Maybe it's something that doesn't get seen. So that's not important. Number of printed circuit boards that have to be designed, you can have up to 4. And so we're going to say just 1. And then it's going to have some designation. We'll just use 1. And is a second spin likely on that board? Let's say it is. So that adds what that's going to do is add a second string of projects. And again, this is all built into the master network to begin with. And all we're doing is either narrowing it down or including them based on the answers to the questions. Is a product safety certification going to be required? We'll say yes, so that'd be UL, something like that. Do we want to include the impact of lifetime tests in the timeline? And we're going to say no. Why? What's going on there? Well, so there are tests that can take literally 2 years to do. If you're trying to get a product to market in 6 months, you might do those tests so that you have the data, but you wouldn't necessarily want to include them in the plan because you'd never get to your deliverable. So newer revised user manual required. Let's say yes. Now we said no to software. So the number of features, let's go back and change this to yes. And now I can say how many features are going to be in block A for programmer 1. And let's say we're going to have 2 there and we're going to have 1. This is what we're thinking so far. We're going to have three blocks that we have to develop. And then the rest of these we can just leave them blank, or better put 0. Is there internal manufacturing required, or is this going to be done through contract manufacturing? So we're going to say yes. And then that opened up, you can see all these questions. If I had said no, that we're going to contract manufacture this, then is contract manufacturing required? Yes. And is there some sort of CapEx required for that contractor? Do we have to put tooling or whatever it might be at a contractor? But let's go ahead and go back and say that internal manufacturing is required. So we'll say yes there. Is it a new internal process or capabilities required? And let's say no. Changes that impact the environmental health and safety. And let's say yes, we'd want some sort of a review for that. Is there going to be any internal CapEx? Again, if I say no, then all the CapEx tasks go away. But if I say yes, then then we're going to have to get a grant or some sort of a approval on CapEx. New tooling and fixtures required for internal manufacturing. Let's say that's for the beta and the pilot. Contract manufacturing required. No. Now, what could have happened is we could have had internal manufacturing and contract manufacturing. So, for instance, for an electronics part, we could do, we may be manufacturing the final product, but we buy the boards from outside and put them into the product when we design it. So there's options that way. And then again, contract manufacturing, CapEx required? No. Is a stage 3 prototype required? And we're going to say yes. Manufacturing location for that proto is going to be in the US. Stage 4 beta required. We're also going to say yes. And manufacturing location for that beta is going to be also in the US. And same thing for the stage 5 pilot. So this is the scale up. And what's the So this needs to be yes or no. In this case it's yes. And the manufacturing location for that pilot is also going to be, let's say, the US. Now, when we after we've answered all of those questions, then we're going to come back over here and look at resource assignments. So who's the project leader? Well, let's say that it's going to be one of our mechanical engineers from the US. Who's the product manager? Let's say that it's a product manager for, and this is product, not project manager. Let's say it's the product manager with this designation. Now you notice in each of these cases, I've got names I can actually use, and what happens there then is not only does you get a resource type, which is used in your critical chain calculations to make sure you're not overusing resources, but you can even assign it to a particular individual project manager. An individual task manager, the person that is assigned to mark that task done, work on it, and mark it done. Then, who's the lead for the proof of concept number 1? And let's say that's also one of the MEs from the US. And let's say Parker is managing the project. So let's say it's Eric here that's going to be the task manager doing the work there. And by the way we've got it set up here, project managers can be any function. Or any function that is allowed to be a product manager, but you could also just have a dedicated group, a project management office, and the project managers would be chosen out of that group. For the second proof of concept, again, let's say R&D US, and let's say it's still going to be let's say we're trying to do these in parallel, so we're going to have Casey's going to work on that one. And then who's the primary mechanical? And so we choose, we're going to have David Parker doing the primary mechanical. Maybe it's not a lot of work, so he can manage the project too. Then here, who's the ME for that proof of concept? And again, we're going to have, we'll have David as that. Then you can fill out each of these, the primary EE, the electrical engineer for the proof of concepts. Again, and these boxes open up with names when we get there. And then you might have electronic document systems, CAD, machinists, all sorts of different folks that are involved. And then if you've got software, you're going to have who's the software lead. So we've got some software engineering and engineering group here, and maybe that's going to all be done in the U.S. And these will all be done in the U.S., and then I can actually, again, even fill in names as we go. Right, so we can pick names and have folks assigned to each of those. And then we've got who's the manufacturing engineer, so who's the support person. These are the people that we're trying so hard to get to the meetings and get involved. So we've got them as part of this. And then we've got who's the quality assurance lead, and then who's the supply chain or procurement lead, so that we get all of those folks in to the meeting. Now, once we've got that done, then we're in a position where we can go and work on a few more details. So for instance, so you can see over here on the software features, we can enter the names of the different software features that are going to be required, and how many blocks of, and how they progress across blocks of development. And this way it ends up, this actually drive menu or refined settings menu or joystick drivers actually end up being integrated into the task names, so that in your planning software, we know which task we're talking about. They're not just generic software components, although we can lay them out generically and in blocks that make sense. And we've got, this is a 3-block setup. You could have a 10-block setup. It just depends on what it is, what is going to work for your organization. So then if we move over to components, you'll see that we've got a couple of components set up already, but let's say that this project was going to need a third component, and that was going to be an aluminum casting. We could say yes here, and then this pops open, right? And we're looking at, in each case, we're looking at what's the sourcing complexity, along with, as you can see, a definition. Are new molds going to be required? How is it going to be shipped? Because that does impact the time. Is a beta parts order going to be required? Is that going to require molds for the beta? And really throughout the whole acquisition of the product, the component, all the way from initial sourcing to having it ready for the first pilot and production runs, you've got the capability to answer all of those questions, drawing on that data that you had that you're going to have your development people, your support people are going to provide. And we'll talk about that in a little bit. The next thing is a test pick list. So here you can see we've got some tests selected, system gain tests at the proto stage and at the beta stage. You could also have it at other stages, but these are typical. And so you can come here and from a whole menu, you can select what are the different tests that are going to be necessary, and those all have data behind them, so that you know how long they're going to take, both for setup and for and you can have a setup task. Sometimes in testing, a lot of times the test will take a certain amount, will take maybe a month. But the setup is 2 days, and nobody has to touch it for another month. It just sits there and runs on its own. So it might actually only be 2 days of somebody's time, but the test is running for a longer period. And this allows you to sort of capture both of those things. It's built into the test. Then when we've answered all those questions, we come to the final project sheet that the team comes together, and basically all of the tasks that are going to be necessary are going to be white. You can see these are grayed out. That means that they were not necessary as a result. And then also here we've got some tasks that have got that are orange, and these have variable durations. So the team should generally go through all of these, but most importantly, go through these orange ones. So here's a benchmark study for new components. Is this going to be none, so it doesn't have any complexity? We don't, or is it low, medium, or high? Come down here to a non-invention study, non-interference study request, low, medium, high, again at each stage. And what these are doing is choosing times from the data that we have. And the team can basically look at all of these to make sure that, and that's all they have to, that's really all they have to do in here. That, and they can come in and either agree with the full kit or and leave it alone. If they agree, then it'll automatically be whatever the suggested. You can see we're using Exapron as the planning software, but this it can work with other planning softwares. But here you can either leave it empty, or you can override it. You can say, you know what, we think this is actually going to be 2 days based on this, this, and this, and then you'll see if we do override it. There's a place over here for the comments as to why we overrode it, and then we can also look and see what our project cost is going to be based on the time that's been put in, and again some background information on the hours and everything. That is all automated. That all comes directly out of what those questions that were answered. And then the last page. So on this page, this is where we're actually going to export the finalized project plan to the planning software. We're using Exapron for that, but again, you can use whichever one. It'll work with any planning software. And so we can choose here which stages do we want to export, and you have to export them one at a time, but although you can have a combined plan that has multiple stages. It'll only have one final deliverable, but you can have multiple stages in there. And then we also have the ability to either run network tests. It adds a lot of time, and if you haven't changed the network, there's not really any reason to do it. So we'll say change that to do not run the network tests. And then we can import it directly via the API. That if you've got a cloud-based tool like Exapron is, you can do it via their API. And then if we were to click on import to Exapron, it would pop up a login menu where you put in your credentials and then push the entire finished project with everything you need directly into the tool. You'd be ready to run the critical chain and push it right into production if you were in a big hurry. Then alternatively, you can also import it. You can import it using a downloaded Excel file, and again, just click on import to Exapron. Same thing happens there when you import it. So that's kind of the flow of moving all the way back here at the beginning from project entry, having that meeting and answering those questions, entering software features, entering components, testing that's going to be included, the team going through the durations, and then going through your final export into the software. Now, you may not do that with the team there. The final import, that might be something just that the project manager does. But basically, by the time you get to this exercise, you will be in a situation where you've got all the information you need, and that the team has been the one that's agreed to those numbers. But instead of taking a day or two to build that plan and go through and argue about everything, you've automated that, and it's based on data that they've all agreed to. In fact, they supplied the original data. You're just now making it a configurated project using the data that they've supplied. So I hope that was helpful to give you an idea of how a configurator can be used and what it can include. Let's take a few minutes to discuss what it takes to implement one. The first thing I want to address is who can implement this kind of automation. Basically, any project environment with repeatable elements can be automated for much faster planning. Some examples would include product innovation, new product development, software, even in an agile environment, design of all sorts, construction of any scale, Again, basically any environment with repeatable elements from project to project. And to get started, you only need to have a good master network with every stage, work lane, and task included. And if you're using templates, that's likely what you've already used to whittle down projects into individual templates. You're also going to need to bring together your cross-functional team's expertise so that they can create the data that drives many of the durations. Some examples of that would be, for instance, here what we're seeing is a chart showing all the different lead times for components, if you have to buy out components. And those are broken down into low, medium, and high complexity, all the different types of components, what happens if you have to have a mold before, and then even you can do those by region. So if you're sourcing them from the US or China or Europe or wherever, but this is the kind of data that you need to be able to get from that cross-functional team. So there is an investment of time on their part, but it's a one-time investment that you can then leverage over and over again. Here's another example showing you, for instance, in testing. So you have some sort of performance testing going on, and what you can do here is, if you look at, these are the different tests, the amount of setup time, the amount of what the test resource is, who the function that's going to be doing it, the duration in calendar days or hours, depends on what your situation is. So you can basically set up all that testing so that you can basically make sure that when tests are chosen, the right amount of time goes into the configurator. Now, I said I'd also talk about a few of the complexities and complications that we end up with. And so one of the first ones I wanted to share with you is this, is that when you've got networks, large networks, and so some of the configurators that we build have over 1,000 potential tasks. But honestly, any individual plan, particularly if you're breaking them down into stages, is probably going to have less than 100 tasks. And so that means you're going to have many tasks with zero duration. So to be able to make that network much easier to view, you really don't want to import all those zero duration tasks into your planning software. And what that means is that you've got to be able to delete. Let's say if I wanted to delete this task here, I need to be able to delete it without harming the network. But as you can see, if I delete this one, all of a sudden I've got tasks A, B, and C without any successors, and E, F, and G without any predecessors. So the solution we hit upon was to write some VBA code in Excel that basically rewires the network. And that's how you have to look at it, right? Essentially connecting every predecessor of the deleted task with every successor, with every one of its successors, so that when the task is deleted, you still end up with a valid network. The other thing you have to do is make it easy for an administrator to maintain the network and the back-end data. Because one, there's no way you're going to get everything perfect when you get started. Coming out of the gate, you know you're going to find some things that you need to update. And then just additionally, the data needs to be dynamic over time anyway, because supplier relationships change, new equipment comes in that has different times, new tests are going to be added. It needs to be very dynamic. So my other piece of advice here is to make sure that the tables and data are easy to maintain. And I'm going to show you how we did that with a macro-driven maintenance menu. So what you're seeing here is this is the configurator we already looked at, but if I click on switch to maintenance mode, what you see is a little login pops up, and that's because we want to password protect this so that only the administrator has the ability to modify it. But then what happens is a menu pops up where you can choose to edit all the different tasks, and this is how you get access to those sheets that I showed you earlier. But then we can also even enter network edit mode, and here you can see we've got the ability to go in and add rows in the network, renumber the network, all sorts of different capabilities, even the ability to validate the network, because after modifying a network, it's really easy, unfortunately, to create a circular reference, those kinds of things. So this is a way that we get around that by building all of that in here to the network. And then when we want to go back to the rest of the configurator, we just click there, and we're back in the configurator. So returning to my earlier story, that client ended up saving thousands of hours in planning and full kitting using a configurator. And with nearly 1,000 projects completed at better than 90% on time, having those plans also saved them untold delays and helped them get in excess of 30% more projects finished without adding staff. And we know how important that is these days. So before we move over and start taking questions, with all due respect to Old Honest Abe, I have just one simple question for you. And that is it time to move past sharpening the axe and automating your planning and full kitting? And if you'd ever like to get in touch with me about help making revenue growth with new products your competitive advantage, or about building a rapid project configurator for your company, here's how you can do that.